and welcome to the Edupedia world. In this tutorial, we'll continue studying streams and file I/O. So let's begin with the topic where we left in the previous video. So now we have to start with writing a character to a file. Now this is unexpected little complexity. Now let's see how can we write a single character to a file. Well, the method's write character has an annoying property. It takes an int, not a char, it's an argument. But it's easy to fix. Just cast the character to its int. For example, to write a character A to a file opened previously, we can write it as OutputStream dot write char, and then we can cast it to int. After that we can pass A. So like this, since this method takes a int, so anyways we are passing an int, but we want to pass in character. So we have passed A by converting it to a character using this method. Or just we can use a automatic conversion from char to int. Then writing a Boolean value to a file. Boolean values can be either of two values, true or false. True and false are not just names for the values, they actually are of type Boolean. For example, to write the Boolean value false to the output file, we can write OutputStream dot write Boolean, and then we can find false or true. So this will actually write the Boolean value to your file. Then writing strings to a file. Now let's see how can we write a string to a file. We have already seen how to write a character. Now let's see how to write a string. Well, use the writeUTF method to output a value of type string. There is no writeString method. UTF stands for Unicode text format, which is a special version of Unicode. Then Unicode means a text which is a printable code that uses 2 bytes per character. It is designed to accommodate languages with different alphabet or no alphabet such as Chinese and Japanese. Then another representation we have is ASCII. So ASCII is also text printable code, but it uses just 1 byte per character. The most common code for English and languages with similar alphabet. After that, we have UTF is a modification of Unicode that uses just 1 byte for ASCII characters. Now, this allows other languages without sacrificing efficiency for ASCII files. Now, when using ObjectInputStream to read data from files, how can we do that? Well, for that, input files are binary and contains any of our primitive data types such as int, char, double, etc. and string type. Now the files can be read by Java program but are not printable. The Java I/O library must be imported including the line such as import java.io.star. So this line is actually importing all of the Java I/O package. After that, it contains ObjectInputStream and other useful class definition. Then I/O exception might be thrown. Now let's study opening a new input file. Well, similar to opening an output file, but we have to just replace output with input. Now let's see how it is done. So you see the file name is given as a string. The file name rules are determined by your operating system. For example, Windows has some specific rules for naming your file. Similarly, it goes for Unix and iOS and so on. Now, opening a file takes 2 steps. Creating a file input stream object associated with the file name string. So first you have to create a file input stream object which will be associated with your file name. Then connecting file input stream to an object input stream. Now this can be done in one line of code. Okay, now this is an example of opening an input file. So you see, to open a file named numbers.dat, what we are doing is we are just using one line of code. You see there's an object input stream and its object is called inStream. Then we have new object input stream, and in that we are passing new file input stream. So new file input stream is containing a parameter which is a file name, which is numbers.dat. Now numbers.dat is actually passed to file input stream to create an object of file input stream. The object of file input stream is passed in object input stream finally to create an object of object input stream. Okay, so in this way we can open the input file. Now constructor of an object input stream requires a file input stream argument. The constructor of file input stream requires a string argument. A string argument is an input file name. The following two statements are equivalent to the statement at top of the slide. The file input stream, we have created an object as middleman equals to file input stream, and then we are passing this middleman to the object of object input stream, which is input stream. Okay, so above line can exactly be written by the two statements which are these. So this was about opening an input file. Now let's do some object input stream methods. Now for every output file method, there is a corresponding input file method. You can read data from input file after it is connected to a stream class. Use methods defined in object input stream. So these methods are readInt, readDouble, readBoolean, and there are more of them. Now note that each write method throws IOException. Also note that each write method includes the modifier final. So each write method does include a final modifier. So that means you cannot change the definition. Now input file exception. So we'll see what all exception that opening an input file can give you. So well, a file not found exception is thrown if file is not found when an attempt is made to open a file. That's obvious, because if a file is not found, then your JVM will eventually throw a file not found exception. Now each read method throws IOException. If you're trying to read something from the file and there is no content, or there is some other problem, it's not opened in a proper read mode, then it is going to throw a IOException. We will have to write a catch block for it because we have to handle this IOException. Then if read goes beyond the end of file, an EOFException is thrown. Now EOFException is end of file exception, which means your file has ended, but still you are trying to read it or write it, or whatever, then it will give you a end of file exception. Okay. After that, let's see about avoiding common object input stream file errors. Well, there is no error message or exception if you read the wrong data type. So if you're trying to read a wrong data type, then there won't be any error message or exception. Input files can contain a mix of data types. It is up to the programmer to know their order and use correct read method. The object input stream works with binary, not text files. As with an output file, close the input file when you are done with it. Now common methods to test for the end of input file. The common programming situation is to read data from an input file but not known how much data the file contains. In this situation, you need to check for end of the file. These are three common ways to test for end of file. One is put a centennial value at end of file and test for it. Other is throw and catch an end of file exception. So you can eventually put a try catch to handle it. Third one is test for a special character that signals the end of file. So we can even test for a end character. Let's say the end character is a special character, or it's EOF file. Then we can actually test using a while loop, like while this is not read, keep on continue reading the file. So in this way we can actually test for end of file. Now what is EOFException class? What is end of file exception class? Many, but not all methods that read from a file throw an end of file exception. End of file exception when they try to read beyond the file. All the ObjectInputStream method in display 9.3 do throw it. The end of file exception can be used in an infinite while true loop that reads and processes data from the file. The loop terminates when end of file exception is thrown. The program is written to continue normally after end of file exception has been caught. So this was about end of file exception class. Now using end of file exception. So let's see a program over here and let's see how end of file exception is actually handled. So you see inside the try loop we are having a object input stream and we have opened a input file which is numbers.dat. After that we are printing some lines such as reading all the integers in file numbers.dat. After that again we are having a try loop. So this is a try loop. And then inside it we are having a while loop. So we are keep on reading it while true. So we are just keep on reading it. Okay. So even if the end of character is got, then also it will keep on reading it. But since the end of character has got, so when it will try to read like input stream dot read it will throw an exception which is end of file exception. Now we have placed a catch block to actually handle this end of file exception. Inside the catch block, we're just printing end of reading from file, and once it's like ended, we are closing the input stream. Okay, so you see that unintentionally infinite loop for process data from input file. So this is actually an infinite loop, and how it's only going to end? It's only going to end when we get an exception, which is end of file exception. Okay. So even after the exception is captured in the catch block, the processing will continue and it will close the input file using inputstream.close. After that, you see this try catch block has ended over here, and then we have also ended the first try block, that is this one. It's going to end over here. Then for this try block, we are also handling a catch block which is taking care of file not found exception and IO exception. So in order, note that the order of catch blocks, the most specific is first and the most generic is the last one. Okay, so in this way we put the catch block inside this code. Now binary IO for class object. Read and write class object in a binary file. The class must be serializable. Import java.io.star, implement serializable interface, and then add implement serializable to heading of class definition. This can be done like public class speeches, then implement serializable. Now serialization is an important concept and I think you should really concentrate over here how we are using serializable interface, which is a marker interface, to do serialization of objects while reading and writing them. What do you mean by serialization? Well, serialization means, let's say if I'm having an object of a class employee and my employee is containing certain data and it is maintaining certain state, then I want this object to be stored in a file. Now, how will I store this object? One way is to read the data from the object and then one by one read name. Then we are going to get employee name, get employee ID, and then we are going to store it in a variable and store those variable in the file. But in this case, are we actually storing the object? No, we are just storing the data. But what we actually want to do is we want to store whole of the employee object in the same state, whatever it is having currently. So in order to state the complete object as it is, there are methods which are like read object and write object. But in order to maintain the state of our object, we should or we must use serializable, that is we must implement serializable interface. So this will make sure that your object will remain in the same state as it is right now, even after you try to read it or write it after a long time. Now methods used to write our object is called writeObject. It is our method of ObjectInputStream. And to read the object from the file, we have a method called as readObject, which is from ObjectInputStream. Okay, now you can see an example. In this example, we are having output stream equals to new object output stream, and then we are having file output stream. So we are actually reading speeches.records over here. Then using an object of object output stream, we are actually using a write object. So you see over here we are having a species is a class, and we have created an object of species which is one record, and using a constructor we have specified the values. Now we want to store the complete object of this class, that is one record. To store this object, we use the method as writeObject, and we pass object in it as it is. Okay. Now while reading it, what we can do is we can create an object of input stream and then just take a dummy object of species which is read1. So this is actually used to read the values. So what we are doing is we are actually calling read object, and then we are passing like one record. Why one record? Because one record was something we actually stored using write object. So we actually want to read this one record. So we have to give the same object which we want to read. So since we want to read this one record, so we are passing one record and this object and the output, so that the value of this one record is automatically copied into this another object which is read1. So you see, read object returns a reference to the type of object, so it must be cast to species before assigning to the read1, because by default the return type of read object is object, but the object that we are reading is of type species, therefore we should cast it to species before assigning it to read1. Okay, so this is how read object and write object work with the help of serialization. Now let's see how serializable interface impact read and write operations. Well, Java assigns a serial number to each object written out. If the same object is written out more than once, after the first write, only the serial number will be written. When an object is read in more than once, then there will be more than one reference to the same object. If serializable class has a class instance, the variables, then they should also be serializable. Why aren't all classes made serializable? Well, the security issues. What is the security issue? The serial number system can make it easier for a programmer to get access to the object. So you see that a serial number is assigned to each object, whatever we are writing using write object. Now if same object is written more than once, then we'll get to know how, using the serial number. After first write only, the serial number will be written. Okay. When an object is read more than once, then there will be more than one reference to the same object using that serial number. Okay. Now, if serializable class has an instance variable, then there should also be serializable. Okay. And why aren't all the classes made serializable? Because serial number system can make it easier for a programmer to get access to object. So each and every object is assigned a serial number, so it will become very easier for a programmer, whether I should rather say in this scenario a hacker, to hack your objects. Okay, so this is one of a security concern. That's why we are not making all the class to implement serializable. And obviously it doesn't make any sense, because if we are not intending to write our objects, then why to make each and everything implement serializable? Okay, because it's a system dependent data. Okay guys, so this was about stream file IO. Now let's summarize everything we have studied so far. So we started with the text files. Now text file contains string of printable character. They look intelligible to humans when open in a text editor. Okay. After that we studied what are binary files. Binary files contain number or data in a non-printable code. They look unintelligible, that means unreadable to humans when opened in a text editor. Java can process both binary and text file, but binary files are more common when doing file IO operation because it is more closer to the machine. So it's simpler for the machine to understand. Now the class ObjectInputStream is used to write the output to a binary file. Then the class ObjectInputStream is used to read the input from a binary file. Always check for end of file when reading from a file. The way you check for end of file depends upon the method you use to read the file. The file name can be read from keyboard into a string variable, and variable can be in place of a file name. Now the class file has a method to test if file exists and if it is read or write enabled. Fine. After that we studied about serialization. We studied how serializable class object can be written to a binary file. Okay guys, thank you very much. So this was about streams IO and files in Java. Hope you have enjoyed it. Thank you.